Assalamu alaikum. I'm Muhammad Suhaib Abdullah. Welcome to my PSM1 presentation video for research based. So for my research title is implementation of k-nearest neighbors and random forest based wrapper feature selection for breast cancer classification. So for today's presentation, this will be the outline. Firstly, first would be introduction and then problem background. After that, it will be objectives, the scope of research, literature review, methodology, and finally, we'll end it with implementation and outcomes. So without further ado, let's start with the introduction. Cancer is one of the most significant medical challenges in the current world. It's a disease where our body cells spiral out of control and grow rapidly. These cells then spread throughout our body and start to disrupt the function of our organs, which becomes fatal for us. And there is no specific cure. So, according to Bray, 9.7 million people died from cancer in 2022, while there were about 20 million new instances of the diseases. They also estimated that 1 in 5 men and women will ultimately develop cancer, and 1 in 9 men and 1 in 12 women will pass away from it. There are no remedy for cancer, but we can fight it. So after detecting, the doctors usually perform chemotherapy on the patient, and sometimes the patient gets well, sometimes they don't. So it depends on when the cancer is detected. So if they detect the cancer too late, then the survivability rate will go down. So it's really crucial to detect cancer as fast as possible. So next is our objective. So for our objective is to identify the most significant feature to determine the rank of the essential features. So this will do with KNN, random forest, and genetic algorithm. And then another objective is to implement the classification model using support vector machine and particle swarm optimization method to find the breast cancer classification solution. And finally, the last one is to evaluate the performance of SVM and PSO in identifying the cancer class. Up next is scope of research. So for this research, we're using breast cancer dataset such as the Wisconsin Diagnostics Breast Cancer. And then we are also using wrapper feature selection such as a random forest genetic algorithm and KNN to identify the top significant features from medical dataset. Also, this study will implement SVM or PSA to classify the model of the medical data. And to perform all this classification and feature selection, we're going to use Python 3.10.12. Next is literature review. So for our literature review, we divided into 3 parts: data preparation, feature selection, and classifier. So in this presentation, I won't mention all of the sources, but I will just mention the most interesting one. So let's start with data preparation. So data preparation is really crucial because it can impact the results significantly. According to Mohammed et al., they performed dataset preparation, removing missing data instances and find imbalanced data and manage those by adjusting the training set balance. And finally, they used a resample filter to rebalance the data artificially. Their accuracy improved 96.9% to 99.5% with SMO classifier. So you can say that the result of this study can be enhanced by performing data preparation before starting the classification or feature selection. Next is classifier. So the classifier, what it does is it categorizes medical diagnosis information into predefined classes by using machine learning algorithm. So in a study by Habibi uh, on breast cancer classification, he combined PSO and SVM to enhance the SVM's performance. He did it by using SVM parameters value to regenerate parallel velocity particles, which were later used to check their fitness value and update the position and velocity of the particle. With this method, the model's accuracy reached 77.60%, where the previous accuracy was 75.66%. Recently, much research has been done on hybridizing PSO cancer classification. But PSO can be used as a classifier, but mostly researchers use it with hybrid classifier to enhance the performance of other classifier. So there exists a space to perform classification using PSO alone. So next is feature selection. So feature selection, there are multiple type of feature selection, filter, wrapper, or embedded feature selection. But since we're start doing our research based on wrapper method, so mostly we did our literature review on wrapper method only. So in wrapper feature selection, it uses different algorithm to minimize the feature of the data set. It combines variables from dataset to find the relation and interaction between these variables and then enhances the classification process. So in a study by Al-Noami, they used wrapper method using sequential backward searching method process consisting of training the classifier and on subsets of N1 features. The subgroup with the lowest predictive accuracy is removed, repeating it until it reaches local maximum. So with their method, they reached 92% accuracy and precision, whereas whereas with RF classifier, they found 81% accuracy and precision. So they found like SPM works better with their dataset. And another study was done by Kumar and Singh, 2020, where they used wrapper method with enhanced gray wolf optimizer, where the SVM was used as the classifier. Their method utilizes position vector and step function to identify if a wolf or a feature will be selected, and later those feature will be used to perform classification. Their proposed EGWO enhanced gray wolf optimizer provides 98.2 for accuracy, whereas the normal gray wolf optimizer provides 97.01% accuracy. So up next is methodology. So this is our flow of our methodology. So what we did propose was we will use the data set, and from this data set we'll take the data and perform feature selection using random forest, k-NAR snipper, and genetic algorithm. Of course, we'll do data pre-processing before and then perform this feature selection. After that, we will categorize all the features based on their ranking, and then we'll use only the top 10 selected features with the classifier. So when we use this feature as an input for the classifiers such as SVM and PSO, it will uh, provide us, theoretically, it will provide us with a better result. So to do that, we'll compare without using the wrapper method. So for that, we'll just directly take the full features from the data set, and then we'll run it by as an input for the SVM and PSO optimizer. So after that, whatever the result is, we'll compare both. And there comes evaluation of classification result. So this is basically the flow of the methodology. So let's go on further. So from our methodology, our phase one is data pre-processing and feature selection. Right after collecting the data, the first step will be to start data pre-processing. And in this phase, we will do data labeling, cleaning, label encoding, and splitting will be done in this step. After everything is done, what we will do is we use the pre-processed data for the feature selection. Oh, another thing to keep in mind is we have to label it based on what classes we will use for the classification. So after that, the feature selection will uh, provide the best features, and with those features in phase two, we'll do model training. So for model training, we'll use 80% of data, and for next will be validation, which will use only 20% of data. And these data were splitted in during phase one. Okay, so after phase two is finished, it will provide us with the output, which would be the accuracy, precision, and how the model's performance basically. So those performance would be evaluated uh, based on their numbers. So we will compare with how each classifier performed on our data set with our model. So after that comes implementation and outcomes. So for implementation, but firstly, as mentioned before, we're doing data preprocessing, right? So the first step would be the basic step is to check for the null value. So as you can see, after I ran the null value checking for the data set, it returns 0 because inside our data set there is no null value. So after that, we perform other data preprocessing like cleaning and splitting as well. So another thing we did is we checked all the data type. So as we can see from here, the data type, every single data type is on float, except for the diagnosis. But we need to change that in order to do the classification. So how will we do that? What we do is we change this diagnosis into two parts. So it has only two type of value, which is B and M. One is benign and the other one is malignant. So what we do is we change the malignant with 1 and benign with 0, which is a binary number. So then everything will have same type of data. And also another thing to remember is at the beginning, we had 32 data in total, 32 features in total. But what we did is we removed the ID since it doesn't have any effect on the data set. That's just used for to keep track which patient has what data. Okay, so moving on. Then, so in this here, you can see the importance of feature with RS. So what we did is, after we finished the data pre-processing, uh, we fed all the data inside the feature selection process. So here we use only random forest. So random forest algorithm takes in all the data from the data set, and then it performs its feature selection. So it checks whether which feature provides better performance in order to classify. So based on that, it's actually organized in an ascending order. So you can see here from area 3 has the best response, and then concave 0.3, radius 0.3, then concave 0.1. So these are their importance actually. So these are ranked by importance. Okay. So from this, we only choose the top 10 data, uh, top 10 features, and these features will feed onto the SVM classifier. So in the SVM classifier, what we do is we train the SVM classifier. So after training the SVM classifier with 80% of the data, then we perform the validation. After validation is done, this is where we are doing the output to check whether it's working or not. So here we can see the precision is 1.0, which is actually good. And then the recall or sensitivity, whichever you want to call it, it's 0.92. So so it's 92%, 92.8% to be precise. And then we got the accuracy of 97.37%, and the area under the curve is 99.87%. Keep in mind that this is with our proposed model. So it's just an initial implementation. Okay, so later on in PSM2, we'll do the full scale implementation where we'll check with which uh, which feature selection performs better with which classifier. So we have 3 feature selection and 3 classifier. There's 2 classifier. So that means we'll have 3 different results for each classifier, which means we'll have total 6 tests. So this only just shows the first one. And then we also need to do it without using the feature selection method so that we can compare whether our model is effective enough or not. So that's it for my presentation. Thank you for watching.